Uses of polarisation. If I take a piece of Polaroid and place another piece over the top, aligned with the first piece, most of the light passes through both pieces of Polaroid. However, if I take two crossed pieces of Polaroid, effectively no light passes through. We can see that in these two photographs. Here I have two pieces of aligned Polaroid, and you can see the light passing through from underneath. And here two pieces of crossed Polaroid, with no light passing through. Here we have two pieces of crossed Polaroid with a perspex set square in between the two. You'll see here no light gets through, and also here. But where the perspex is in between the two pieces of Polaroid, light does get through, different colours getting through in different regions. You'll notice here there's a crack in the set square, and there's a large range of colours around this region. This technique can be used for stress analysis. A perspex model of a structure such as a bridge can be placed between two crossed Polaroid sheets, and this highlights the points of stress. The perspex rotates the plane of polarisation of the light having passed through the bottom piece of Polaroid, allowing some of it to pass through the top piece of Polaroid. The amount of rotation depends on the wavelength of the light, hence the different colours, and also on the degrees of stress within the perspex. Some liquids also rotate the plane of polarisation. One of these is sugar solution. This can be investigated with an arrangement something like this. We have a light source sending light through a filter, so we're only dealing with one wavelength of light. The light then passes through one Polaroid filter before passing through a container of sugar solution. It can then be observed through a second crossed piece of Polaroid on the top. From above we'd see something like this, with this being the top piece of Polaroid and this being the bottom piece of Polaroid. At the moment where they're crossed, no light passes through. This would be with water in place of the sugar solution. However, as we increase the concentration of the sugar solution, to get all the light stopped, we need to rotate the top piece of Polaroid, something like this. What we can do then is measure this angle theta. And what we find is that as the concentration of the sugar solution increases, the angle of rotation of the plane of polarisation, i.e. the angle theta here, also increases. This is used in the sugar industry to accurately measure the concentration of sugar solutions.